All right, we're going to start with an introduction to perception and action. So the question is, why study perception, right? How do we know how we perceive things? Well, how do you know that when you look at a cup, it's a cup? Well, you just look at it and you know that it's a cup, right? It's simple. It's the most natural thing to do, right? When you look at someone's face, who's a friend of yours, say, oh yeah, I know that, I recognize that. But we don't look at the complexity of the processing, the neural processing that goes into it. It's easy to do, right? Maybe not an intelligent act at all. Well, it turns out it's really a hard task if you try to get a robot or a computer to do it. So the goal is to create automated systems, right, with visual functions. Seeing robots that can recognize your face, right? If we were really this good at being able to just produce these kind of feats in machines, you wouldn't need a PIN number for your card. In fact, you wouldn't need a bank card at all. You could just walk up to an ATM and say, hey, it's John, I need about $50. And the machine would say, oh, hey, John, I recognize you, right? Recognize your voice, recognize your face. I know you. Here's your $50. I know it's your account. We don't have machines that can do that yet. We have machines that can beat the expert chess players, right? Deep Blue and Watson are really examples of really smart cognitive processors, right? That can do things that humans can't do. But none of them are as good at recognizing faces or recognizing voices. The perceptual end of it is really, really complex. The computer programs that are required for driving a car, those are just really kind of starting to come around right now, and the processing that goes into that is amazing. So I posted a video that you should watch on really what goes into driverless car. But it's something that if you know how to drive a car, you do it with ease, right? And so the trick here is to create an autonomous vehicle that can perform better than a human person. Aren't humans persons? And we've done that, right? So they're just really going overboard on the testing to make sure that there are no PR mishaps, right? So if we have this crazy thing where people start getting killed by autonomous vehicles, then it gets bad press. It's not going to happen. There was actually someone who was killed by an autonomous vehicle, but that's one out of I don't know how many hundreds of millions of miles driven. So autonomous cars, even at this point in the development, are safer than cars driven by humans. So something to keep in mind. Here's the complexity, or part of the complexity. This is a screenshot from the video that you should watch that shows all of the sensors that go into a car, all of the things they're doing. Infrared sensing, they're doing camera sensing. And there's a database, right? So you have to know if you're designing an autonomous vehicle, you have to get the car to understand that when there's a cop going like this, that means that you stop. And when the cop goes like this, that means that it's okay to drive. And they're doing that. The point here is that the process of perceiving things, even though we can do it in a blink of an eye and it seems effortless to us, there's a lot of processing that goes into it. We're not aware of it, right? It's not a paradox because the perception that we do, most of the neural processing that occurs for that is outside of our awareness. So we've got tons and tons of brain structures that are involved in perceptual processing, right? But much of this is outside of our conscious awareness. There's a lot of heavy lifting that goes on in recognizing a face. But it seems effortless to us because it all takes place under the hood outside of our awareness. So what do we take from this? This is a course that is going to study how the brain and the body bring about your conscious perceptions. We are looking at how action interfaces with and guides perception, and which assumptions the brain makes in order to simplify perception, right? Your visual field is really complex, and your brain makes a lot of guesses sometimes about what's the best interpretation of this scene. And we can do that. We can look to any kind of illusion that you've ever seen that shows that there's not this isomorphic or one-to-one relationship between what's out there in the real world and how you're perceiving it, right? All you have to do is take a pencil and put it into a glass of water, right? And you see that it kind of bends a little bit, but it doesn't really. It's an optical illusion. Your perception of the world, your visual perception of the world, is not accurate in that case. And any other illusion that you've ever seen is further evidence for that. The motion after effect, which there's a video up on Moodle, take a look at that. If you stare at this display as it's moving for a long time, you're going to get some pretty dramatic motion after effects, right? When you look at the wall or look at your hand afterwards even, it's going to be all moving. And you know that it's not, but your visual system is telling you that it is. So there's not a one-to-one relationship between what's out there in the real world and what you're perceiving. So claim number 2 is that in order to construct the external world, your brain makes decisions, and arbitrary decisions sometimes, about the structure of a stimulus. So you've seen the Necker cube, you've seen the Rubin face vase illusion, right? Which is it? Which way is the cube kind of protruding, inwards or outwards? Do you see faces or vases? You can switch it back and forth, right? So initially your brain is making an arbitrary decision. We have much more complex examples of the face vase illusion, right? So which way is the face facing? If it's facing towards you, or is it facing to the left or right? So what do you see here? Do you see people or do you see animals? So if you look, there's people here, there's eyes, a little baby down here. But if you look at the space in between, you see either a dog or over here perhaps a rabbit, but there's 2 people, or a cat, right? So it's the same concept, only a little higher fidelity, right? Claim number 3, there's an interaction between perception and action. Your motor system can influence your perception. Even brain areas that are not really devoted to perception influence perception. Here's a quick example, and hopefully it'll work better on your screen than it does in class. So here's one example. If you look at this display and just kind of scan your eyes all over it, it looks like it's moving. The things are just kind of rotating a little bit back and around, but they're not. There's nothing moving in this display. And in fact, if you just fix your eyes on one particular spot and don't move them at all, then all the movement stops, right? Because the movement that you're perceiving in this display, even though it's not there, is based on your action. It's based on the action of you moving your eyes around. So, perception is the end result of this massive neural computation that we can't yet faithfully reproduce with AI. We're getting there, but we're not there yet. And perception and action are coupled. The influence of your motor system on our perceptual processes is profound. And we'll get some more evidence of that in our next video.